It's my great pleasure and privilege to introduce Paul Buzilă from the Faculty of Foreign Languages at the University of Bucharest. Other than being an outstanding Spanish teacher, Paul is also the heart and soul of the Center for Cognitive Neurolinguistics, CELIN, here at the University of Bucharest. And I am very much looking forward to his talk. Thank you for being here, and let's hope to many more joint ventures between philosophy and linguistics.
Yeah, thank you, Andrei, for this kind introduction. I hope everybody can hear us online. So thank you for the invitation, and thank you for insisting with this invitation, because first, let's say I didn't dare to send an abstract. I'm a linguist, so first I thought I'm not totally competent to address the issue of LLMs. Yeah, just a small correction, let's say, on the program. Also, there's a typo. It's the first time I introduce myself as well as part of the CELIN, which is not a neuro-linguistic circle. Actually, neurolinguistics is part of neuroscience. I'm not doing neuroscience. It's neurocognitive linguistics. I know they got confused a lot. So CELIN is this monthly event that we are doing where we are discussing language from a neurologically plausible point of view, let's say. And we're happy that we are turning 1 year at the end of this month. That's an online event, so you're all welcome to join if you're interested. Now, coming back, as I said, I'm mainly a linguist, and what I'll try to do today is maybe not what the title of my presentation promises. So what I'm trying to do actually is just to bring some maybe new perspective from the neurocognitive linguistics, also known as relational network theory point of view. Because I'm going to present briefly what this theory is all about and how it sees linguistic meaning and how it could, or what it could bring to the discussions we are having. Because from what I've seen yesterday and today, basically we are revolving around this question if LLMs actually produce language as we know it, let's say, or as we refer to it in humans. So I'll try to refer to that, more focused on the issue of meaning and understanding meaning. So I think I can pretty much rush through the introductory part, because we've discussed these things several times in the previous presentations, but mainly I'll just mention the two standpoints, two main positions that I could understand from the literature regarding LLMs understanding meaning. So there's probably the mainstream idea that they don't, and they refer mainly to two main arguments. So several researchers mentioned first the lack of the ability to encode abstract symbolic structure, and then the second one is the lack of sensory motor grounding. And because of this, of course, the conclusion will be that meaning cannot be learned only from form alone if there is no content. Now, recently there are several opinions going against that mainstream position. So there are researchers that say that actually LLM can learn to encode many aspects of the traditional symbolic structures, or even if they don't have this sensory motor grounding, they say that ungrounded language models can encode actually a conceptual space, which is structurally similar to a grounded space. So, or even more extreme opinions that say that meaning arises strictly from conceptual role, which is defined strictly by relationships between internal representation of states, so they don't need any kind of grounding. That is the position defended by Piantadosi, for example, who, by the way, and we heard it a few days ago in Alexandru Nicolae's talk. Piantadosi also claims that LLMs discovered grammar just by doing statistics, the statistics they do. Because also there's this idea that statistics in this, from this point of view, do amount to understanding in any falsifiable sense or for any practical reason, for example. So all this would amount to the main idea that language understanding could be actually dissociated from all the embodied and the emotional characteristics. Okay, so we have these two positions, let's say. Now, of course, when talking about meaning and understanding meaning, we should first try to specify what we mean by meaning, but that would be a very huge enterprise, let's say. In philosophy and philosophy of language and linguistics, there are so many ways of understanding meaning. I don't even dare to review them, just to mention that the spectrum of definitions, let's say, go from a strictly or definition that strictly sees correspondence as the main or reference as the main point. That is, meaning is what refers to this connection between linguistics forms and something in the reality, something material, up until the other extreme where we have like pragmatic theories where meanings depend on context or depend on these conceptual roles. So if I just resume, I mean, if I just want to see how this concept is seen in the debates related to LLMs, what I could see that in the recent papers, meaning is also seen by different researchers on this spectrum where we have the same kind of extremes. At one extreme, those who prioritize reference, so this relationship to the world and the material world, things in the world. And then at the other extreme, we have the concept of conceptual role, where meaning arises strictly from a relationship between concepts, and everything can be specified by these kind of relations. Now, what I want to do actually is just to bring to you a kind of not necessarily new perspective, but maybe less known. That is the perspective this type of dual linguistics has, which is called neurocognitive linguistics, is also known as the relational network theory. It's a model of language developed by the American linguist Sidney Lamb, first developed in the 50s and 60s. That is, it started along with Chomsky and grammars, but then developed later on, and let's say a full-fledged version of it is presented in a 1999 book titled Pathways of the Brain, the Neurocognitive Basis of Language, where let's say that the first version of the theory goes beyond a mere linguistic attempt at explaining language, because it posits as a main thing neurological plausibility. So it imposes on itself this criteria of the neurological plausibility, trying, of course, to bridge a gap between linguistics and neuroscience. Okay, so in this view, I will just formulate the definition of meaning and then explain it. In this view, meaning is actually a network representation distributed in linguistic, conceptual, perceptual, and motor subnetworks. And I will try to explain what that means in the following minutes. So very briefly, the main tenets, the main ideas of this view on language, which, as I said, is also known as relational network theory. I will refer to it in brief RNT from now on. So the main idea is that linguistic system is a relational network consisting of nodes and connecting lines. From this point of view, for example, linguistic units of any kind, phonemes, morphemes, syntax, whatever, are not objects. They don't exist, let's say, in reality, but network representations. And I would add one more idea. Linguistic system is connected to all other cognitive systems. So what does that mean? In order for you to get let's say a grasp of what this means, I will just show you briefly this issue of linguistic unit and how we see linguistic units in neurocognitive linguistics. So it's like a shortened version of a demonstration that Sidney Lamb did. Linguistic units traditionally were known to have, for linguistic units, relationships are very important. So that was a known fact since de Saussure and Hjelmslev. So what Lamb did was actually trying to specify very well the role of these relationships, the kind of relationships a unit has. So we'll just take the example of a morpheme, a simple morpheme, which in this case is also a word in English, cat. We know this morpheme, let's say, has different kinds of relationship with other kinds of units. For example, if we go towards the phonetic expressions, we know that this morpheme is composed of smaller units, like the phonemes, all right? But at the same time, it has some relationships with the meaning, the concept cat, or also a function from a syntactic point of view, let's say, in that case, a noun. Being a noun makes it useful in certain constructions, so that's a function. So we know this morpheme is related to all these other units, but then RNT devised a notational system meant to clarify also the types of relationship that we posit among these units. So for example, if we think about relationships that morpheme has with the phonemes, we are using this kind of node. It's a conventional thing to use it to use a triangle for that. We call it an AND node. We also have OR nodes, but this is an AND node because actually what happens is that for the morpheme to be produced, you have to produce in sequence k and e and t, of course. So it's kind of an AND processing. So the three phonemes have to be produced. Now, in a relational system, in a network, what does that mean from a process point of view? If we think about the morpheme as a node in the system, we posit activation on this node. So if this node is active, it will actually send activation through the AND node and activate the three lines for the activation of the phonemes and then for the phonetic production. And actually, we can think about that, the linguistic processing in these terms. So for example, if in the system, the conceptual node is active, and at the same time, the function node is active, they send activation to this upper node, which by the type of node it is, will activate only if it receives activation from the two lines, because it's also an AND line. So it needs activation from one line and the other in order to get active. And if this node get activated, it will activate the morpheme will activate this node, and as I explained earlier, will activate the lines going below. Now, the discovery of RNT was that in this kind of network system, we actually don't need this label cat here. It's just a label helping us to read the diagram, because the processing can occur without that label being there. So just briefly mentioning again, if the cat node is active, the noun node is active, they will activate these two lines. The node will get active because it receives enough activation from both lines, will activate the line going downwards, and the node, the downward node gets active and then activates the three phonemes. So no need to interpose, let's say, any other unit, any other object in between. And that was, as I said, a great discovery, because from this point of view, the morpheme is not a unit, it's just a location in the network. And if we extend this reasoning to all the other kinds of units, actually we will realize that any kind of linguistic unit are just locations in the system. So I expanded a bit this diagram here. We can say the same about these three phonemes that we had in the previous diagram. So we know from linguistics that phonemes actually mean bundles of articulatory features. So we can assume as well that that is represented by another end node, which will activate the respective articulatory features. And then articulatory features, actually, if we think to articulatory phonetics, means the movement of certain articulatory organs. So in the end, actually, that means activation of certain muscles. So all the units that we can think of would be in this view just labels that help us read this kind of diagrams. But the system they don't belong to the system. The system itself is made only of nodes and lines interconnected in such a way that the language processing can occur. So, and here a brief parenthesis. From this point of view, so any linguistic unit, as I said, is a point or a location in the network. There's a long debate in neuroscience about local or distributed representations. Now, from this point of view, it's more or less the same. I mean, we can think of the morpheme cat as being a point in the network, or being actually all the points, all the nodes and lines directly and indirectly connected to that point. So it can also have a distributed representation. So what the morpheme in linguistics used to be in this model are actually either location in the network or the whole subnetwork connected to that location. Okay, so how is that helping us understanding meaning? Well, that helps because we understand that conceptual nodes, for example, are also just nodes or just locations in the system. So the meaning of the concept cat, for example, is not anything else but a location, that's the local representation, or the whole subnetwork connected to that location, to that node, that is all nodes and lines connected to that cardinal node, let's say, which would be the concept cat. That's the distributed representation. Now, the thing is, and that's related to the third and last idea that I mentioned earlier, the conceptual node is not only linked to a linguistic subnetwork, but is also linked to perceptual subnetworks. That's the idea that I mentioned earlier, that linguistic system is intimately connected to sensory motor system, and actually to all other cognitive systems. So how would that be represented? Let me see. Oh, I just hit okay. Yeah. So if in brown I'm representing here, let's say the linguistic system, we can imagine all those subnetworks that I showed earlier with a lexical node on top, cat, and that would be connected to the conceptual node cat, but that conceptual node is also connected actually to similar subnetworks in different perceptive modalities. Because we know the concept cat is not purely linguistical. The concept in our mind gets gradually built based also on perceptual information, from auditory system, for example. We can assume there's a subnetwork there that has on top the percept, the auditory percept of the sound a cat does, right? Then we have visual system, which would have on the top of the subnetwork the visual percept, that's like the abstract or the ideal image of a cat, and so on in tactile olfactory systems. And all these would be connected to this conceptual node. So if we talk in general terms, we can say that a concept is basically a node in this huge network connected to percepts and to lexemes as well. So a concept from this point of view would be just a cardinal node in a network. That's the local representation again, or the whole subnetwork connected to that cardinal node, or better said, all subnetworks connected to the cardinal node. So that cardinal node would actually integrate percepts from different modalities, perceptive modalities, but also would integrate these percepts with the lexeme. So if we go back a bit, we can imagine again that subnetwork explaining the linguistic relationships of the morpheme cat that are also connected to function and then connected to this conceptual node. But the conceptual node is also connected to similar subnetworks in different modalities. And this is what I mentioned earlier as a OR node, because we can assume that in the system that, like, for example, if we talk about perception now or input, when we hear, let's say, the lexeme cat, the conceptual node can get activated, but also when we see a cat, also when we hear a meow and so on. So that's what this node represents, that any of these percepts, any of these percepts or the lexeme itself can activate the conceptual node actually. Besides that, the theory posits also let's say a number of connections between concepts, so interconceptual, let's say, connections. So this is just a representation of some of the connections this conceptual node might have. So it might have those connections with percept, like example with the visual system, and so on, with the tactile system, but also with some other concepts within the same conceptual system, like feline. How do you pronounce this? Felina?
Feline.
Feline. Feline, which in turn would be connected maybe to lexemes, like to feline, but also with cat maybe, and so on. So if we see things this way, we can think about the linguistic system connected to other system as a sort of cognitive dome, where we have on one side phonology going to lexis and then entering the realm of the conceptual system called here a sememic system, which is connected to sensory motor system and then connects back to reality, right? So this phonology and let's say input from sensory organs, for example, are the two interfaces with the real world. Now, what happens between the lexemes and the concepts, we call that inner semantics. So it's the relationship between lexemes and their meaning, and the relationship between concepts, the meanings, and let's say the outer world, cognitive realm, going from phonology through sememic system to the outer world again. The whole thing would be called semological structure. So that is the relationship between lexemes and the world via sememic structure and perceptual motor systems. Okay, so what does that all mean for our discussions? Well, this model of language says that meaning are subnetworks made of all nodes and connections directly or indirectly connected to a cardinal node, conceptual node. Okay, so from this point of view, then meaning is based on both sensory motor grounding, as it's mentioned in literature, and construction of conceptual nodes. In other words, going back, meaning relies also on inner semantics, the relationship with the strictly linguistic system, but also on outer semantics, the relationship with the world. Now, from what we know, LLMs do not have a relation network architecture. We know they rely on artificial neural networks to have the processing power, but the kind of the architecture the LLMs have are based on statistical learning and statistical prediction of next word and so on. So the kind of internal representation they might have are not based on a relational or on a network architecture. That would mean basically that they lack outer semantics. And here I would add just that I referred only to chat box. I know we talked in some other presentation about chat box being integrated with sensors in some kind of robot. And my question would be also as well, how are they integrated? Because they would have to be integrated in this kind of network architecture in order to produce the same kind of internal representation. And then the inner semantics that they might have, we know also that it's not the kind of inner semantics that we have, because again, the architecture is not a network type. So they would also lack inner semantics in relational terms. Of course, that would still leave us with the problem, how do we explain the surprisingly good performance that these chatbots have in conversation, let's say, with humans? Again, as I said, I don't intend to come up with an answer because I don't have it. I just wanted to bring this perspective of relation network theory and how it sees meaning to the discussion. But my intuition, my intuitive answer to this question, so how come they do that good? Do they really use language as they do? Would be summarized in this assertion. So I think that just like nature produces every now and then random forms that have meaning to us, LLMs produce with trained ability, of course, linguistic forms that have meaning probably or possibly only to us. And with that, I thank you very much and open to questions.
Thank you so much, Paul. Now let's open the floor to questions. Mitch?
Thank you so much. I enjoyed that a lot. Just a question about costs.
Sorry, about what? Sorry?
Got a bit of cost.
Okay.
Just a question about the last couple of slides that you had about internal networks. So, one of the dominant philosophical positions in philosophy of mind for the last 30 or 40 years is functions. The idea that that's going to imply that human minds, as it were, instantiate mentality in one. But there's no reason why something similar kind of mentality could be instantiated in different architecture. So it seems to me a proponent of LLM meaning could say they just happen to do it in a different way. But it doesn't matter how you're instantiated, just as, whether you play chess on one kind of board or another kind of board, you're still playing chess. So too, the proponent of functions would say LLMs might just instantiate in a different way, but as long as the performance is up to our standards, then they should be credited with the relevant kind of semantic proficiency. So I guess I'm wondering about the move from our architecture as posited by RNT looks a certain way to therefore anything that has a different architecture doesn't have meaning. That strikes me as potentially making you subject to the kind of parochialism criticism. So I'd be curious to know how you respond.
Yes. So I'm not sure if the audience online could hear, so I'll just summarize. So the question, if I understood it right, is from a functionalist point of view, we should accept the fact that if LLMs seem to produce, let's say, language with the same results, but on a different kind of architecture, we shouldn't just rush and say that's not meaning, that's not understanding. And I totally agree. Yes, that's why I said maybe there's another kind of internal representation, another kind of understanding meaning, which, by the way, for all practical purposes, seem to work just fine. I mean, we heard about examples of people going to LLMs like to a therapist or to a friend, so that works. So I agree. The only comment I have here is that as linguists, we are interested in anything that could teach us something about how human and natural language work, because we don't know that for sure. So if we think about LLMs as a possible way of learning how natural language works, then we have this doubt. Like functionally, yes, maybe it does the work, but I'm not sure if the way it does it the same way we do it. So as a linguist, maybe we can still learn a lot from analyzing and understanding how LLMs work, but my intuition is that they don't have the same kind of processing. They might have the same result output or very similar, but still my intuition is that we process language differently than LLMs. So that's the difference between maybe a philosophical point of view and a linguistic point of view.
Sure. Yeah, just a quick response to that. I think you can ask the question, two different questions. One is, how can we understand human mentality, including linguistic capacity? And how can we understand mentality per se? That might be a more general question.
Yeah.
Different statutes.
Yeah. Thank you.
Great, thanks both. Ivan?
Thanks a lot for the talk. I didn't come across this relational network. I can't remember what the acronyms were, but it's very interesting to me. I like this distinction between answer and semantics. What I was a bit surprised by is I can certainly see how language models lack outer semantics. They lack these connections to perceptual motor, perceptual inputs or motor outputs. Excuse me, but I was surprised that you said they don't have inner semantics. It seemed like the reasoning was something about the architecture of the means that they're not network as systems. But presumably this theory, even though it is kind of neurally, there's an attempt to be neurally plausible, it was. I'm assuming that it's relatively high level, it's not specific about details of the neural condition, or at least in the way. Yeah. So I can see somebody looking at the structure that we find in the activation space of a lot of language models. There's lots of findings about certain relationships, certain directions in the space that correspond to certain kinds of relationships. The classic example is you take the vector for man away from the vector for king, and then add that on to woman, queen, take your screw up. So cases like that suggest that there is this rich structure within the activation space of the network. Whether you want to think about that as a network, it could just be that, if you model it at a higher level, it's kind of network-like. We don't, take the network too seriously as far as like the underlying structure or architecture, but it is giving us a nice modeling of what's going on in the space.
Yes. So thank you. So again, rephrasing it briefly, I think the question is related to my statement that LLMs don't have internal semantics in the way I presented it. That is because they don't have a relational architecture. And what you're saying is that maybe the kind of architecture they have might be equivalent to a higher level to a network architecture. I would say that I have this, how to put it, I have my doubts as well, and maybe it's what you say, because I don't have, I think I don't have such a good understanding of the technical part of how LLMs work. And I had the same idea actually before the presentation. What if this whole thing about vectors and stuff like that, which have of course a mathematical representation or not, at a higher level, maybe just equate are equivalent to a network, might be. So actually, in the first version of my presentation, I was saying that LLMs did not process language in the same way as we do because they lack external semantics. But then I thought maybe not even the internal semantics are the same. But Okay, so maybe they do have internal semantics. Possibly, yes, I don't know. So then are left with this the second part. Yeah, no, it's possible. Yeah, I think so.
Great, awesome. Thanks both. Let's take two questions online and then come back to what you guys are saying. I'm going to have to switch the audio so that the online folks could be heard.
So should I mute?
Okay. Great, good. So now we have first question, then Yuan. Chris, go ahead.
Thanks very much, Paul. That was really interesting. And this is a very untutored clarificatory question. The sketch of the modeling for human concepts and understandings, and there were lots of links, it seems, between, as you say, like motor systems, muscle systems, and sort of phonetics and the sounds we're supposed to be making. But I was wondering how that fits in with like learning words from text, where we might have totally different pronunciations in our head to the way they're supposed to be pronounced, and we might not be making similar sort of motor movements to what most people might when they are pronouncing the word correctly. So I'm just was wondering what sort of happens there in us as to whether that yeah, all of that is strictly necessary.
Yeah, well, I'm not sure if I understood your question. So your question is, how could we explain in these relational terms different pronunciations, or?
Yeah, pretty much. So the sorts of the sounds that are associated with the word cat. Here, maybe cat's too simple a word for this problem to arise. But I know when I've been reading things, I often, especially if they're derived from a language I'm not as familiar with, the pronunciation I will just get totally wrong. And so like the connections that I would be drawing in my sort of internal system might be very different to someone else's. And I was wondering if there's something to be drawn from that. Maybe this is sort of reinforcing some of what Mitch is suggesting, that there might be some kind of multiple, like lots of different ways that we could do the same kinds of things, or if there's, if there's a kind of easy explanation for how, why we might not always need the same kinds of bits of things to be in the networks.
Yeah, well, within this model, pronunciation, let's say, that is phonetic production of words, of sentences, are just have the same kind of relational representation, because let's say, the parts of the system responsible for producing sounds would be linked to the rest of the subnetwork. So linked to lexemes, to syllables, whatever. But then we have strong relationship connections with visual subnetworks, which would account for recognition of written words, for example, and so on and so forth. So actually, because the subnetwork has the connectivity it has, we can explain, for example, why when reading words in another language, we tend to pronounce them with our native, let's say, way of pronouncing things. Because the connection with the visual system exists, but then when activating the subnetwork for phonetic production, it will activate an already existing network, which by its connectivity will produce the sound we are used to produce. Not sure if that kind of gets close to what you were asking.
Thanks, that's helpful.
Yeah, okay.
Great, good. Thanks both. Next up, Yuan Montan, please go ahead.
Hi, thank you for the talk. Yeah, very, very interesting. I knew almost nothing about this network type. I'm going to kind of fall back a little bit on an older question about these cases, the interface between linguistics and, let's say, philosophy of mind here. I'm thinking in what sense we can account through this model for the compositionality of our mind, in the sense that with a very limited number of mental representations, we can potentially generate an infinite number of statements, almost like in logic or in the sense of compositionality, like Fodor talks about this. If this is a problem for both cases, like the human type of linguistic reasoning and for the network reasoning, because it looks like the networks do have that problem, cannot generate this potential infinite number of representations from a limited number of items or tokens, whereas we can, in principle, play with the word cat and mat and hat to infinity, right? Just combining them based on some limited number of rules, like you do in logic, standard logic. I'm curious if that's kind of a separation there, sufficient condition to say that LLM cannot do that, whereas humans obviously, potentially at least can. That's the compositionality. And then there is systematicity of the same Fodor-Pilishin type of question. Yeah, thank you.
Yeah, thank you. So I think there were several questions there, but addressing the main one about maybe the this capacity of innovation and producing like an infinite amount, the possible amount of sentences, of words in humans. Relational networks don't have this issue, let's say. Of course, I don't have time to go into details. And what I presented, like for example, this diagram would only represent a very, very small part of the subnetwork. But to account for what you said, actually, I would have to present the way RNT sees learning, and for that, we use what is called the abundance principle. That is, on a diagram like that, I'm showing only certain connections, certain nodes, but there are many others, and there are degrees of strengths between these nodes. So the idea would be that there are very, very, very many, not infinity, of course, of nodes and connections, and the process of learning actually means gradual strengthening, selective strengthening among certain nodes, which become dedicated to processing a certain kind of information. So from this point of view, innovation or producing many other even unheard linguistic forms before is just a matter of building new connections, which is not actually building new connections, but strengthening latent connections. So, as I said, the theory has a lot of other details, but yes, it's taking into account this. And actually, the abundance principle is a principle that can be verified from neuroscience. You know that there's a huge number of neurons and connections, many of them latent, and that can be anytime become active when exposed to stimuli, or when a new pattern, internal pattern, actually needs to be represented in some way.
Thank you. Thank you. Very useful. Thanks.
Great. Thanks both. Just a really quick question, and I didn't start here. So what about cases like hot, right? So when I say that this is hot, that something is hot, right? I could, if I'm a child, refer to the sensation in question, or later on, I learn a bit of thermodynamics in high school. Even later on, I learn a bit of statistical mechanics and so on. And so my theoretical concept of heat changes along the way. But that never stops me from saying, the mug is hot because I poured some coffee in it. And so it sounds as though there are competing theoretical concepts I have of heat that I pick relative to different contexts. And I don't ever lose the concepts I gained as a child, right? When I learned these things. And so, is that, will there be different theoretical representations that are activated in different contexts and they're all sort of with me, so to speak? Or?
Yeah, so what you're saying is actually referred to what we call in polysemy, like a word having different meanings. So what you experience as you go through life and get a richer and richer experience, you, let's say, acquire different concepts that in your cognitive system, little by little, will be linked to the same lexemic node. So somewhere in the linguistic system, you have that node, which would be represented in such a diagram with the lexeme part. But then that's connected to one concept maybe at the beginning, but then gradually it can become connected to other concepts. So the concepts are different. We have to use a word to refer to a concept. But what you get is not a concept getting modified, but the addition of different concepts to the system, but all linked to the same linguistic form concept.
Right. And these are all sort of agent internal, right? So I could use the thermodynamic meaning and you could understanding in the statistical mechanics, right? And we would still be able to successfully converse about heat.
Yeah, I would say that one of the concepts and not the others will be activated depending on several factors, of course, which will be represented in a network by several nodes. And usually what happens in this kind of networks is that, let's say, neighbor nodes, like in this case, this concept that will be linked to the same lexeme, would have interconnections of the inhibitory type as well, in such a way that when one gets sufficient activation, it immediately sends inhibitory activation to the others. Let's say just to make sure there are no 2 or 3 concepts at the same time active. And that can be modeled, that is modeled actually in relational networks, and that has neural correlates as well.
Could I just briefly follow up on this? And I know Mitch has another question as well. So I wonder how far we can carry this. So for instance, if there are different interpretations of quantum mechanics, right? Will those simply count as instituting different meanings for some of the key notions, or is there going to be some kind of instability between the concepts that are associated with the same word, such as wave function or whatever?
Yes, and at the more general level, actually, what another strength of the traditional representation is that all these lines and nodes, as I said, have different strengths. So at any given time, there might be several pathways active in the system. And let's say that the one that wins is the strongest, and that would be, let's say, the thing that gets understood. But then you have the idea that there was some other meanings floating around. And that's because there was activation in the system on those pathways, right? So, and that's why also how we can explain some instances when we don't understand what we were supposed to understand, or when we don't say what we wanted to say, because the relational network architecture allows, let's say, for this kind of
search architecture.
Yeah, search like when maybe because the activation goes on several paths, maybe at a certain moment the path that was not supposed to be active is active, and you just have a slip of tongue, for example. Like many linguistic theories, for example, cannot account for errors and stuff. A relational architecture.
Great, awesome. Thanks so much. Let's go ahead.
Just very briefly. One, just in defense of the possibility of LLM actually having external. I have never had a direct causal contact with Napoleon, like to refer to, because I'm the beneficiary of long causal
pain is to go back to initial baptism. That's a relatively widely accepted view of philosophy of language. And if I can refer to Napoleon by virtue of my causal connection, as opposed to having seen it myself, why can't we say something like their use of word during their process are beneficiaries and non-causal change? Even though they've not had a direct causal connection, they've got indirect causal connection, but I only have indirect causal connection with Napoleon. So it'd be helpful if we could say more about precisely what is the principal barrier that makes one say that relevant method. Whereas, given that, maybe most of them.
Yeah, so I'd say that partly I would agree with you, and maybe meaning can arise strictly from internal presentation and term semantics. Partly I would somehow disagree because, like, your experience with Napoleon, let's say, as you said, is not based on direct sensory motor experience, but let's say the concept of Napoleon that you learned along the way in your life was built, let's say, based on a sort of internal semantics, so relating to other concepts you had, which were related to other concepts you had before, and so on and so forth. But at a certain point, those concepts on which your concept of Napoleon relied had some grounds. I mean, you have some sensory motor grounding of what a man is, what a king is, maybe because it's in pictures and stuff like that. Maybe you even saw pictures of Napoleon, but even if not, even without seeing pictures of Napoleon, you got explanations about what Napoleon means. It was a man, it was a leader, it was stuff like that. And all those concepts that are used to build the concept of Napoleon at a certain point have some sensory motor grounding. So from this point of view, your concept of Napoleon has an indirect grounding as well. Whereas in an LLM, I think that's not possible. So you would have to rely strictly on internal.
Well, I mean, it's still going to be causal relation between the LLM and that word specificity. After all, you got training done doing line replay users and themselves, beneficiaries, etc. So I think what you're really pressing is the sensory motor. You're saying that an LLM can reference it doesn't have sensory motor connection.
Yes.
Just the fact of having causal connection. Okay. Not to be enough to the referential switch. I think that would be more argument, but I see where you're going.
Yeah, actually, I'm not sure if it's not enough, as I said. So maybe it's enough because I don't know exactly if such an LLM can have a certain, can understand somehow meaning based only on internal representation. Maybe there is sort of meaning.
I would say internal representation of causal connections.
Okay.
Causal connections.
Yes.
So like within 15 years, robots will be able to, transfer what you visually see into text in a reading mode. Like, will that fix the problem? Depends on how circular that sensory motor.
Yeah.
I would say it's a problem. Oh, I apologize. Yeah.
Theory on it. So the issue I want to talk about those lines between the nerves involved. When you answer some questions, I think I already got that. They are not causal relation, right? Because the sensory was always to react in a certain way and so on and so forth. And if they are not causal relations, we can do. And the people are schedule ascending to this view according which the meaning of norm. And it's okay. I mean, it's when an ongoing debate in the field of the language whether renal is normative or not. But with non-normative meaning, you're going to find the same architecture in some animals as well. Some sensory prompting, which is recognized as the presence of a predator, and which then causes them to signal the presence of a predator. So, then I think having this sort of architecture is in a way specific to human language or communication. And then not having this sort of architecture is not relevant as well. But yeah, that was. I was just curious, how would you react?
Yeah, well, as I said, this is a linguistic theory that appeared out of the, let's say, need or attempt of understanding human language, of course. So, yeah, and by the way, whatever we are doing in neurocognitive linguistics is related to how the system of an individual works. So it actually tries to understand the neurological reality actually that lays behind what we call language. Of course, the relational networks are at a higher level of explanation, let's say, but the idea, the attempt would be to understand finally what those lines and nodes mean. They definitely don't reflect neurons and axons, definitely, because the way they work is more complex. But they might be similar to the way, like, for example, neural columns work, where we have tens, hundreds of neurons, for example. The lines would pretty much work like bundle of axons, probably. And then if you think of biological neural networks where activation means electrical chemical signal going from one neuron to the other, if that's an instantiation of causality, yes, the same thing goes here.
From what you say, there are some causal relations as opposed to, for instance, inferential relation. As in
No, yeah. Like if I have 1 minute, like as an anecdote, Sidney Lamb developed this theory at the beginning purely on linguistic information and terms. So he was not thinking about the neurological realities at all. But after devising this way of representing language processing by means of relation networks, in several conferences, people would start to tell him that they resemble neural networks. So that's when he actually decided to study neuroscience to see if there's any connection, and then further develop his theory. So, yeah, I mean, at the beginning was not meant to represent biological networks, but in the end, we realized that there are strong correlates with neuroscience.
Thanks so much, both. And I think this is quite fascinating. It also, this kind of multi-level architecture is also a call for a richer concept of causation. Right.
By the way, if you are interested to find more about this theory, at the end of the month, as I said, we have this 1-year anniversary event, and Sidney Lamb accepted my invitation to be present and to get some questions. We have pre-submitted questions, and we'll just present them to him and hear his opinion. He's 95 or 96. I hope he's still able to join us and do the talk. But yeah, so if you're interested, you're welcome to write me an email, and I will send you the details for the meeting. Yeah, that's what I said. Yeah.
Well, let's hope for many more opportunities. And are there any other comments, questions for joiners? Take one, take two. Please join me in thanking Paul.
Thank you.